Okay, here we go. We are going to look at a worksheet here where we are trying to figure out, we want the integral. Let me go ahead and make sure we got a pen. So we have the integral of 0 to 2 of, or actually we're looking for the volume of revolution of the square root of x, e to the negative x over 2. And we want the volume of revolution between 0 and 2. So the first thing we have to do is we have to go ahead and apply our volume of revolution problem, our formula. So we're going to say this is pi integral of the square root of x times e to the negative x over 2. I'm going to put this in parentheses here and square it dx. All right, we can go ahead and start that. Let's see if we can do this a little bit. We'll make this a little bit thicker so we can see a little bit better. All right, now let's go ahead and square it. Now you need rules of exponents. We're going to square the square root. We have pi integral 0 to 2. Squaring the square root, we end up with an x. Rules of exponents. We have x over 2 here. When we have an exponent raised to an exponent, we multiply the exponent. So that's going to be e to the negative x dx. Now we're ready to go ahead and try to integrate this thing. I moved the pi outside of the integral just because we can always move constants outside of the integral, and I'd rather deal with it on the outside rather than on the inside. So we need an integration by parts. So we're going to say set u equal to x. Okay, and my du just equals dx, or dv equals e to the negative x, v equals negative e to the negative x. And I think that's kind of what you guys wanted to have happen here anyway. Okay, all right. Probably should have zoomed in a little bit here so I'd have a wider screen, but there we go. All right, that didn't help. All right, so here we go. We'll zoom on. All right. So the way we do integration by parts is we draw this little diagonal and then we go back. So you make a little box. All right. So we have pi and we have negative x e to the negative x because I'm multiplying these two together. So I have x times negative e to the negative x minus the integral, right, of negative e to the negative x dx. All of these go from 0 to 2. All of them go from 0 to 2. Both of these parts go from 0 to 2. All right, so let's go ahead and we can clean this up a little bit. So we have pi sitting here, and then we have negative x e to the negative x. We have plus integral, because negative, negative, 0 to 2, e to the negative x, dx, and we are ready to integrate this thing for the last time. So here we go. We have pi, we have negative x e to the negative x. I'm going to go put parentheses there, minus e to the negative x. Now we've integrated it. We have to go from 0 to 2. Boy, there's a lot of negative signs here. I don't like negative signs. Could we factor them out? I'll go ahead and factor out both of the negative signs for this one and this one. So we can say this is negative pi times x e to the negative x plus e to the negative x. And what I'm going to do is we're going from 0 to 2, but I really don't want to deal with the negative sign. Could we do this instead? Can I say this is pi times x e to the negative x plus e to the negative x? Or make that an x. And instead of having the negative sign there, we're going to swap the order of integration. We're going to go from 2 to 0 rather than 0 to 2. And that eats up the negative sign. Now, I think let's go ahead and change this, make sure that's an x. There you go. Okay. So notice both of the negatives on the ground, on the baseline, they got factored, and then I used them up to swap my order of integration there. Now we can go ahead and plug in some numbers. So we have pi, and I've got 0 e to the negative 0 plus e to the negative 0. Okay, minus, and then we have 2 e to the negative 2 plus e to the negative 2. Okay, and it's just plugging in my zeros and plugging in my 2, and then we're ready to go on with what's going to happen with this. Okay, we'll make sure we're multiplying the whole thing by pi and not just that first part, but we'll go through the whole thing. Well, here's why I did this. 0 times e, well, I don't care what e to the 0 is anymore because it's 0 times that. So we just have a pi. This whole thing is 0. And then e to the 0 is plus 1. Okay, minus. And then we have 2e to the negative 2. Okay, and then I'm going to put a little guy right here. We have plus e to the negative 2. All right, so we have 2e to the negative 2 plus 1e to the negative 2. Oh, that's going to be kind of nice. So we're going to have 1, right? We're going to leave the pi outside for a little bit longer. So we have 1, right? Minus, and then here we have 2e to the negative 2 plus 1e to the negative 2. That's 3e to the negative 2 all times pi. So this is going to be pi minus 3 pi e to the negative 2. That's the answer that I want. And I told you guys, hey, we could do this as a calculator exercise. You don't have to do this as a whole thing here. So what I'm going to do here is I'm going to bring up Desmos. Now, you're not allowed to use Desmos on your tests, but I'm just going to use this as a thing. I'm going to use it to check my work, and I'm going to use it to make sure I got the right answer. Okay, so I'm going to type in I want integral from 0 to 2. Okay, now this is the thing I'm going to be checking against. All right, and then here we have. It's not going to square it for us, so I'm going to go ahead and type in pi. Oh, so I don't want that. I want out here. I want pi times, right? Just type in pi and it goes ahead and does that. And then what's the squared version of my integral here? And it's just going to be x. So we have x e to the negative x dx. You need the dx in there for everything else, for everything to work out. Okay? That's the number I should get. Let's double check this and make sure that we actually did our arithmetic right when I go through and do the problems with this. We can go ahead and see what's happening for that. All right. So let's just go ahead and deal with this as a calculator rather than anything fancier. All right. So let's see. We go down here. And what did we end up with? We ended up with, I'm going to just type it in. We have pi minus 3 times pi, and then times e to the minus 2 power. We'll see what we have there. Okay, and I just typed it in, and what I'm trying to do is like check it. Does is what I got the same as what the integral calculator got? And it uses Simpson's rule. It just uses much smaller intervals than we ever will. So that's just an idea of like you want to check your work. Yes, you can absolutely check your work and make sure you did it right. And this is how you did it. Okay. So I'm good to at least a few decimal places. So I'm going to say that I think that's okay. I think that's what we did with this. So I'm going to go ahead and close our video here and say, okay, if you did the problem, that's really good. I like this problem. Be aware that you're going to see it in the future on your test. Okay. So thank you very much for watching the video, and we'll see you next time.